file size in storage. So let's add that into Civil 3D now. So again, we'll do map II for map insert image. We'll go to our compressed tiles and we'll add those, and we'll zoom over to them. Okay, so now that we've gotten over to there, we can turn off our image frame by typing in image frame, and we can set it to 0. And now let's just go ahead and zoom in to see how it handles. So we'll just go ahead and zoom in, and you can see this actually handles really well in Civil 3D, and the image quality is looking pretty good. So let's go ahead and save this out, and we'll put this as drone image. And then now we can close this out. Okay, so now let's work on the surface. So now let's go ahead and add our files here. So go back, raw sensor, we'll add in our ground, which is ground scaled, and all of ground points. Now for the next step, this is a pretty big file, so we're going to go ahead and shave this down to more manageable chunks because we need to do some sampling. So let's grab our rectangle selection segment tool, and we'll just start chunking this up. So once you have your data sets split up, I'm going to do this into 3 chunks. Let's go into our rasterization. For our step size, this is kind of an open country environment. So our target goal is to do a 5-foot sample, and so I do the 3x3 rule. So we need to find an interval that works to get us to 5-foot raster tile size in the end. So for simplicity, I'm just going to start with a 1/2 foot and get the minimum point value in the 1/2 foot cell. And this is why I split my data set up into smaller manageable chunks, so that this can be easier to compute and not take up memory as bad. With these larger projects, it's more and more important to manage your memory. I already have quite a bit of memory out for being able to do this, so we'll just go ahead and do the minimum sample, and then we'll output to a cloud once it is finished. So now that we have that it finished, then we can just output to a cloud, and we can go ahead and delete the original. That'll clear up some memory, and then we can work on the next one. Same thing, we're going to go rasterize 0.5. You can see after clearing out the larger data set after each one that you are continually clearing your memory. So by the time that you get all of your point clouds put out, and so sometimes you get kind of weird anomalies that happen with your point cloud, and you can quickly clear that up, hit the 5 on your keyboard, and then we'll just do a quick snipping and get the points below. and identify ones that don't really make sense. So now we have all of our blocks, and we can go ahead and merge them up. Once they're merged, then the next step is to do our next 3x3, which is going to be 1.5. And we're going to do the average. I've been asked to do 2-foot contours on this project, so this 1.5 sample is going to give us a much closer representation to what the actual ground is going to be doing, since we hunted for minimum first, and then now we're going to do an average to smooth it. And then the last and final step is going to be the 4.5 or 5 foot. We're just going to do for simplicity. We're going to look back for the minimum value, and then we're going to interpolate, but we'll set our interpolation max. And set your empty cell size down to 5,000. You'll see why here in a second. We'll just go ahead and zoom out and then clip this off of here. Make sure to get the right one when you're removing. F8, and then we'll go to Tools, Projection, Rasterize one last time. Turn off our interpolation. This basically fills in the gaps and sinkholes. And from here, you can do a raster geotiff. And we just want our heights. This will be used for a DEM. And now the last step is to contour. So we're going to set our 0, and then we'll set our step to 0.25 and our minimum vertex count, just to ensure that we're not picking up crazy small features like sagebrush and outcrops. This, a little note, is the step where if you have volumes and you're trying to do small stockpiles, then this is going to need to be decreased, but for this data set on a 2-foot contour interval, this is going to work for my site. And the contours look pretty decent. So we'll go ahead and output. And before you exit out, it might be also, well, I suggest doing this, but you can open up a CSV. So your CSV that you had put in, you might want to add in your survey data. So in this case, I'm going to need to re-export my survey data for my control points. So I'll go ahead and select all of my control, and I'll export this into a PNEZD, which is the point northing and elevation. So we'll go ahead and call this ground. Drag and drop the CSV into the file here. Use the previous input. And now, what I suggest doing is adding a polyline. So click on your data set that you want to edit, and then we are going to add a polyline. So you can go ahead and do the trace polyline. So click on your targets here,